notes.
Good afternoon. Please sit. Take out your notes.
Mr. Cruz, may I go to the washroom, please?
Yes. Where are my notes? Guys, turn to page 69.
Hey, where are my notes?
I don't know. I told you it's my bag.
Did you take from me?
Guys, what are you talking about?
You took my notes!
No, I didn't.
But I can prove that this is mine.
How?
Show me.
First, I squeezed some orange juice to drink one day. Having nothing better to do, I decided to write some notes with the orange juice. Realizing I've made my paper wet, I blew it in front of the fan to dry up the orange juice. And now, to prove that the set of notes is mine, I just need to iron and heat that sheet of paper I wrote with orange juice to see the wonder and magic. And voila! The notes I wrote using orange juice have reappeared again. So, how did this happen? First, we'll need to investigate how papers are made.
Subatomic particles, protons, neutrons, and electrons combine to form atoms. These atoms then combine to form molecules. Atoms of carbon, hydrogen, and oxygen combine to form the glucose units which make up the long ribbon-like chain of cellulose. This chain or ribbon continues on for 3,000 to 5,000 units. These long ribbon-like chains are built up into sheets, which are held together by the side-to-side hydrogen bonding between the chains. The sheets are stacked tightly into layers and held securely together by van der Waals forces. This is a microfibril. The microfibrils organize into bundles by the same side-to-side hydrogen bonding and layer-to-layer van der Waals interaction that form the microfibrils. The fiber is formed from bundles in the same way microfibrils and bundles were formed. Glucose molecules are bonded covalently together into long chains. Each alternating glucose ring of the cellulose molecule is flipped over, and the water molecule has been split out, leaving an oxygen molecule between each ring. This chain will continue for 3,000 to 5,000 glucose units. The sheets are held together by dispersion forces. They are then organized into bundles. These fibers are mixed with water and often other chemicals and spread onto a forming screen. They are then pressed together and dried to produce a finished sheet of paper. Esterification is the process whereby a carboxylic acid reacts with an alcohol to form an ester. As there is an OH group present, the glucose rings are able to react with carboxylic acids to form ester. Orange juice contains citric acid. In the case of the invisible ink, citric acid found in orange juice is a carboxylic acid. In the presence of heat, citric acid will react with paper to form ester. The ester has a brownish color, which allows for the message written to be seen. The hydrogen ion combines with one of the electrons being shared between the outer energy level or orbits of the carbon and oxygen atoms. The hydrogen atom now shares this electron with the oxygen atom, breaking the bond between the two glucose units or rings of the cellulose chain. Now, instead of a single long chain, there are two shorter, weaker chains. The right side of the ring is stable because by sharing the electron from the hydrogen atom, the outer orbit of the oxygen atom still contains 8 electrons. The left side of the chain, however, is not stable. The hydrogen ion combined with one of the carbon atom's electrons, leaving the carbon atom with only 5 electrons. This loss of one negative electron means the carbon atom now has a net positive charge, so it is now a carbonium ion. Stronger acids can also be used as invisible ink. When an acid comes into contact with paper, the glucose chains in paper will be shorter, as the glucose chains start reacting with the acid. The van der Waals forces will in turn be weaker as the molecule size becomes smaller. Furthermore, the geometry of the short carbon-hydrogen bonds minimize the distance and maximize the strength between the layers. However, as the chain is broken and rigidity is lost, the carbon-hydrogen bonds are no longer so strongly forced into the geometric plane, which keeps the layers at a minimum distance from each other. A loss of strength is then suffered in the bonding between the layers. The bonds between the glucose rings in parts of the paper exposed to acid are weaker than that of the parts of the paper not exposed to the acid. As such, where heat is applied, less energy is needed to break the weaker bonds. Thus, the parts of the paper exposed to acid burn faster, revealing the message.
Oh, so these notes belong to Dexter. Gates, go to the naughty corner for 2 hours now.
Oops.